on most batteries, not all of them. Number emission system test 8. We're talking about emissions here. And you know, there's a shadowy connection between, there's an intermarriage of emissions and engine performance and electronics. It's all rolled together in a wad, you know. The basis for illuminating the malfunction indicator light is when ignitions exceed the FTP standard by 2.5 times. That is totally wrong. Actually, it's 1.5 times was the, and that may have changed, you know, in recent history, but the original, you know, setup, it was 1.5 times. OBD2 continued the use of manufacturer-specific scan tools as the only way to access diagnostic information. No, that's wrong too. Everybody was supposed to have the same data link and the same protocol under the dash, so that whenever you plug the scan tool in, it could see. Now, some of the Japanese automakers had trouble getting the OBD2 to work. They really did, and like Mitsubishi, in order to hook up to some of those Mitsubishi cars in the mid to late 90s, you actually had to have two. They had a little Mitsubishi diagnostic connector, and they had the OBD2 connector, and you had to have a Y cable to plug into both of them and then go to your scan tool with it. And it was a sort of a, it was irritating to have to deal with that. We had to deal with it at the dealership too. I mean, they could kind of get it to work good enough to pass muster, but eventually everybody got their act together on it. But what got me was Ford, Chrysler, and GM didn't have any trouble with it at all. You know, they just blew right through it. But what we were told in school, to be fair, I mean, I don't know the true story behind that necessarily, but what we were told in school was that the Asian and Japanese automakers in that bunch were having trouble with it. And that's what we were told. And they just barely did squeeze by.
Maybe they didn't want to compromise to American standards.
I don't know. The data link connector must be a 16-terminal connector with some of the terminal uses being predetermined. That is true. Okay, somebody tell me which terminal is power? Come on. That's a ground. 4 and 5 are ground. 16 is power. What I don't want you guys to do, and there's actually worksheets out there that I got on this, is I don't want you, if you plug in and it won't talk, you need to know what to do. You know, this stuff about, well, I don't know what to do because my scan tool won't talk. You know, that is, a lot of people depend so heavily on the scan tool that if they plug the scan tool in and the scan tool won't tell them nothing, they don't know where to go beyond that. And there's some guys out there, there's a gaggle of people out there that have the idea that doing the kind of work that, you know, is related to the drivability and the emissions and all is nothing more than plugging a scan tool in, pulling a code, popping a part on it, and sending it on its way and getting paid the big bucks. And at some of your part stores, they kind of believe that. That they can plug a scan tool in, get a part, you know, tell you about it. I was over there one day, and I happened to be, I was doing something to my Jeep out there in front of the part store. And this woman had this guy, said he wanted to go pull the code. And so he came out there to pull the code. He was a real friendly kind of a guy, too. And so she was saying something about, what about these codes here? And I says, well, you know, a 200 series code's got to do with fuel, a 400's got to do with, you know, something to do with air evaporative.
I got to tell you something. You get
and a 500 series code's got to do with speed, and a 700 series code's got to do with transmission, you know, and all that kind of stuff. And this guy started feeling threatened by that. And so, you know, he was, and we were just out in front of the parts store. I was telling my Jeep, and she was, you know, she asked a question, I was answering it. And it made him mad. Because he's, why don't you let me do my job? I wasn't interfering with his job. I was standing 6 feet away, you know, and we were talking to her. But anyway, I went on and I think I let him sell her an oxygen sensor. The problem was he couldn't put the oxygen sensor on, and if you put the oxygen sensor on and it turns out it had a vacuum leak, putting the oxygen sensor on ain't going to do nothing. See what I'm saying? So, I mean, depending on what your code is. Tell the story.
All right, anyway, that Volkswagen I was working on?
Yeah.
Okay. I replaced spark plugs and one coil pack because it was broke.
Right.
Okay. It drove, you know, when I first drove it, it missed on cylinder 2 and 3. Alright, I fixed it. I was driving down the road. It was fine. The cat heats up. Started missing it.
The catalytic converter heated up?
Yeah. And when I got back to the shop, it was glowing red.
Yeah.
So the cat stopped up.
Yeah. Well, Yeah, but if there's fuel going down there, if you got some kind of raw fuel.
Yeah, but it
down
didn't start doing it until the cat heated up.
Yeah. Yeah, there's obviously a problem there, but overheated cat doesn't always mean that the cat is at fault. Now, the cat may have been destroyed by the previous problem.
I think that's what it was. I think it was dumping raw fuel down in there.
Yeah, and it'll
It'll
overheat it because that cat goes up really, really hot, and if there's fuel in there, and if there's fuel being put in there that goes down through the cat, it can cause it to, glow red and all that. So yeah.
So what do you think's wrong with it?
Well, if the catalytic converter itself, I would to begin with check and see if it was damaged, if it was restricted. That's what I want to know. Is the catalyst restricted? And there's ways that I've showed you up, on the board up here where you can check to see if to begin with, look at engine vacuum, and also then you can look at, I've got a little exhaust gas back pressure checker in here where you screw the oxygen sensor out, screw a fitting in, put a hose on that fitting, and you look at a gauge, and you gotta, and it ought not to have hardly any back pressure at all in front of that catalytic converter. You can also do a temperature gun trick, just as a part of your regimen of tests, and shoot in front of the catalytic, shoot behind the cat, and see if it's getting really hot in front of the cat, but it's cool behind it. Focus on the cat to start with, but when a catalytic converter gets red, that doesn't always mean the catalytic converter is at fault. Sometimes it's just reacting to something that has happened somewhere else.
Well, what I think it is from where they drove it around so much like that.
Very probably, yeah. If they drove it around, it was putting raw fuel in there, and I don't know if that Volkswagen shuts the injectors down whenever the cylinder's not firing or not.
No, they don't.
So you're probably right. The catalyst has probably been destroyed by the previous condition if they drove it enough. Right. So you're probably on target with that. What you wanted to do, if you wanted to try this. And they used to have what they called a tri-pipe, which everybody knows they're going to put one of these tri-pipes on there and leave it on there. But you ain't supposed to do that. But anyway, they would actually temporarily put a pipe where the catalyst used to be.
See, I can't do that because it involves directly.
Yeah, so you ain't no way you can do that.
No.
If you take the catalyst out and, the exhaust is so loud, they're liable to melt something that way too. So you're pretty much going to be, just focus on the cat right now and see if it's clogged. That's the best thing I can tell you about that. So anyway, but yeah, you're probably pretty much on target with that, especially with a situation like it was. Number 4, the misfire monitor uses a principle involving crankshaft rotation in that all rotation of the crank will be uniform and consistent. What do you think about that? Everybody's totally confused. What Chrysler, that's false by the way, but what Chrysler and GM and everybody else, the computer has got to determine what's normal. In other words, it's going to look at these crank sensor pulses on the crank. The crank sensor's got this wheel, and they look different on every car, pretty much. And a lot of them have 36-1 tooth wheel, but it wants to know what, is the normal variation between cylinders, right? Because there's going to be a little bit of product variability in the field. That's just the way things are. And so if you were going to take a snapshot and use it to compare, and that's what now I'm telling you, the PCM does what you guys ought to be doing. Every time you get a chance, anybody that was smart, if you're doing a vehicle inspection, you probably ought to take just a few minutes and plug the scan tool in and look at what normal readings are on the car you're checking, even if it's running great. The more you look at those normal readings, the more you'll be able to recognize bad ones. That's just the way things are. Well, the PCM does this too. Chrysler calls it their adaptive numerator. And when they know good and doggone well that the crankshaft is spinning with a nice even, load, is when you're letting off. When you're letting off and you got engine braking, boo, everything's smooth, nothing is going on, the injectors are shut off, and all this, right? And then it takes a snapshot of that waveform. And it knows, going by the law of averages, how much space there is between each peak on that thing. Now, if there's a little bit of an anomaly where this one and that one's a little farther apart than the rest of them, and that's normal, it factors that in. You see what I'm saying? So basically, it goes out of its way to look at what's normal coming out of the crank sensor. Well, let's say you got a crank that, or maybe the engine has got a place where has a little bit of resistance and it slows down a little bit in this one spot, right? Instead of being nice and smooth, it recognizes that as normal when you're letting off and it gets this reading. Once it has taken this snapshot and it look, it factors in speed and all that kind of thing. And let's say you start misfiring on cylinder number 3 and it's comparing this snapshot. What it's going to see, if I do this right here, since I have an eraser, I like to erase with my hand because somebody has screwed up my eraser. But anyway, if this one here is normal, and now all of a sudden it's comparing that snapshot to one that looks like this, and every time 3 comes around, it's got a slower spot, because what does the engine do whenever you're misfiring? When that piston is not carrying its share of the load, everything slows down for a second, right, at that particular place. So it knows now, because of cam and crank, it knows that's cylinder number 3, so I'm going to get a P0303 misfire. Now, to be perfectly honest, occasionally, it doesn't happen all that often, but it does happen where the computer will misfigure which cylinder is skipping. Don't get thrown by that. If you're checking cylinder number 5 and cylinder number 2 happens to be its companion, you may get a P0305 when it should have given you a P0302. Because we've actually worked on this one cylinder and found out, oh gosh, the spark plug's totally shot on 2. Why was it giving us a P0305? So don't get, don't let that boggle your mind. It's always a good idea to look at the health of every plug and every coil when you're doing that. Anyway, I just wanted to make sure I covered that, because if I didn't cover it, I'd forget it. Number 5, the crank sensor relearn must take place immediately after replacing a crank sensor. True. See? Because every little thing, a lot of times you don't realize just how sensitive this stuff is. It needs to know that. And like General Motors calls it crank relearn, and Chrysler calls it adaptive numerator. And did you know General Motors has even got what they call a bumpy road detector? Because if you're going through potholes and stuff, it's liable to cause stuff that'll trick it into getting a misfire. So it's basically got rough road detection too. It can tell by looking at all of the various sensors it has got when you're bouncing through potholes and stuff. And OBD2 emission components like EGR, AIR, and PCV are all being monitored to ensure they're working properly. OBD2, what do you know about that?
Yeah, true.
Yeah. Well, actually, that is, the system is monitored, but not necessarily the component.
So that's false?
So that's false. Now, how does it monitor? Somebody tell me, and this is, like I say, this is school, this is where you're supposed to learn this stuff, so don't complain. But how does it know that EGR is working? Think about what kind of a rationale. Now you've got to come up with a way. Let's say that you're the engineer, and whoever your head shed guy is, he comes down there and he says, I want you to come up with a way for our engine controller to determine if EGR is actually working.
You put a heat-based sensor in there.
What now?
Some kind of heat-based sensor.
That is a good answer, and the reason I'm telling you it's a good answer is because Asian vehicles do that. That little Maxima that we worked on over there that we put the mass airflow sensor and all on? It's got an EGR temperature sensor. The Asians like to do that. They like to measure the EGR temperature, and that's a good answer, what you just gave right there. Because what? That pipe gets hot, right? Remember what I told you? If you crank it up, engine's idling, you hadn't given it any gas, and you just cranked it up, and that pipe's hot, you know you're flowing EGR, right? Or if the manifold gets hot, you know you're flowing EGR. Like if the manifold is blistering, egg frying hot within a couple of minutes of starting it, and you hadn't given any gas, it's sitting there idling, you don't have an EGR. If you got a rough idle, and you're looking for it, lay your hand on the manifold. If it burns your hand, crap, that EGR is flowing. And you figure out what you got to do. If it be a bad EGR valve, it could be a bad input, making EGR valve open all the time. Anyway, all right. So that's one way. What's another way? What happens whenever vacuum drops? Yeah, some of them will actually measure manifold absolute pressure, so they'll know that they should see that drop when the EGR starts to operate. How does the Ford do it? Remember? They got that little tube over there, and it's got a little orifice in it with 2 pipes coming off. On the Ford one, what they do is you got an orifice right here, and you got a pipe here and a pipe here, and you got a sensor up here, right? And it's reading both of them pipes, and it's got voltage reference and all that. Okay, so when EGR is flowing, what does the pressure on this pipe do? The pressure on that pipe rises, the pressure on this pipe falls, because you got an orifice here. It's a little small right there. So if you got an orifice there, when something's flowing through there, you're going to see low pressure here and high pressure there. It's a pressure differential. That's why they call this a DPFE, delta pressure feedback EGR. That's what they call that. That's a delta is basically a programming term, which a delta is, you know, seen that before. All right, but anyway, so that's your DPFE. That's how Ford does it. GM for years, and I don't know, I think now they're looking at manifold absolute pressure, but for years they would look at the oxygen sensor to see what, you know, what's going to happen to my oxygen sensor output if I'm flowing EGR. How's it going to be different? What are you displacing with this inert gas that's coming through your EGR? You're displacing oxygen. So your oxygen sensor is going to drift a little toward the rich side when EGR is flowing, isn't it? See that? But the computer's going to understand that EGR is flowing if things are working right, and it's not going to go crazy and try, you know what I'm saying? It knows how to make those adjustments on that. So anyway, this is one of the things that, now let me ask you this, how does it check AIR, the air injection system? How does it check that? You got to come up with that too. If I tell you this stuff and you don't get it, it's not my fault, okay? If I'm going too fast for you, it's all in the book.
How does it determine if it's using it?
How to determine the AIR is working? This is sort of a generalization, but what it does is, hey, I'm going to dump some upstream air and see if the oxygen sensor notices it. That's easy, isn't it?
So it works off an oxygen sensor?
Well, the oxygen sensor is actually going to notice it if you dump air upstream. See what I'm saying?
On the oxygen sensor.
Yeah, the oxygen sensor is going to be your rationality check for that. Okay, if I'm doing a rationality check of PCV, how are you going to be able to do that?
See the PCV system's working?
Yeah, I mean, how's it looking at the PCV system? Pretty difficult, isn't it? There's a reason why that question is false. Now there are the PCV system's operating all the time, isn't it?
No, it's not, is it?
Yeah, I mean, anytime you got engine vacuum, it is, and all that. Your evaporative system, some of them operate. They want to know if it's flowing evaporative gas. They got a little temperature sensor for that, but that's the non-enhanced one. You know, anyway, there's a rationality check for all these things. If it tells the idle speed to go up, and it doesn't see the engine speed follow, or the mass airflow, it says we got an idle speed control problem. Because I'm telling it to raise the idle speed, I'm seeing mass airflow stay the same and engine speed staying the same. So I know there's a problem here. See, the computer's smart enough to compare things. If you and I were going to do it, we would go in there and that's why you go to your scan tool and you go to the active command mode. You go in there and you say, I'm going to tell the IAC to increase, and I'm going to see if my mass airflow rate goes up. I'm going to see if my ears tell me the engine's speeding up. I'm going to watch the tachometer too, you know. And if I go, and it's speeding up like that, I say, well, I know that's working, but hasn't met its target. So on the screen it says, I'm shooting for a target of 1200. All it can get to is about 950. We better go find out what's going on. We got clogged passages, we got a bad IEC, we got whatever. All right, anyway, that's the kind of thinking you got to do when you're doing this kind of stuff. All right, now then, let's see, number 7. It's possible for a vehicle to fail a diagnostic test more than once in order to illuminate the mill or record a diagnostic trouble code. Yes, it is. You're going to look in your trouble code repertoire on a good scan tool. They'll have pending codes. These are codes that I've seen this one more time. I've seen this once already. If I see it again, I'm going to turn on the light. The customer doesn't even know when they've got a pending code. They don't have a clue, right? All right. So, number 8, the first digit of the code B1058, signifies it's the first digit, meaning the first number, not the B. Signifies that it's a generic code number that manufacturers will use for the same component and fault problem. That's wrong because the first digit is going to be a 0. On the way that codes are formatted is, and some of your scan tools that are generic scan tools, or if you're in the generic, function of a regular scan tool, if it sees a code that's like a P1540 or whatever, it's going to say manufacturer specific code, which is a little irritating because you really want to know what the code is. You know what I mean? But it won't tell you because all it's required to tell you is the ones that start with 0. If it starts P0 540, it's going to be a speed related code of some kind. Say a P0500 is like a speed sensor code. But a lot of the times your manufacturer codes are a little bit more specific than the other ones. And if you got these little 2-digit flash out codes, you remember how I showed you on the Chryslers, you turn the key on 3 times and it flashes codes out to you? Those aren't typically as clearly defined, even if you find the definitions of them, as the ones that give you that whole thing. Of course, that one vehicle we had in here, when you turned the key on 3 times, it would give you the P code on the odometer, which is cool as all get out. You know, Chrysler did it on some stuff. Number 9, is that where I'm at? Number 9? The trouble code system will usually use the last 2 digits to indicate the specific fault, but may use all 4 digits if necessary. Wrong. Nope. Number 10. Readiness indicator monitors only indicate that particular tests have been run and they still need to be reviewed by a technician to ensure they did not fail. Now that's true. And they have little things, and I don't know if you've ever seen one of these, Wes, but they got these little things that you can just plug into your data link connector and drive that sucker around. And when it has cleared all of its monitors, they'll make a noise or turn on a light, you know. But the hardest monitor to clear without fail on all the ones I've ever worked on is the doggone evaporative monitor. Sometimes you'll drive trying to get it to clear that one, you know. But most of your high-end scan tools, if you've got a car that's got good functionality, will let you perform an evaporative test on your scan tool to make sure that system's okay. In other words, it actually will have it'll seal off the vent, it'll buy some vacuum, it'll trap that vacuum, and you can monitor your pressure. And it's actually, they'll actually have a little, on the scan tools that I've used, the factory ones, sometimes they'll have something like a little range, and they'll have the actual reading, and if it drops out of that range, you still got a leak. See, if it stays in that range, everything's a pass. You see what I'm saying? That's how that works.
Why does GM's evaporative system suck so bad?
I don't know. Everybody's got their own way of doing evaporative system stuff, but and some of them are better than others. I will tell you this, if you ever look at the evaporative system on a Mercedes, you'll be thinking, what in the Sam Hill were these people thinking about? They could have put something in there a lot simpler than that, but they got all these pipes, they got all these chambers, they got all this hogwash. I mean, and if you got to fix something like that, it's a pain. Then you got some of these other ones that say, well, I can't get gas into the car. Well, you know, say, well, that's no problem. I'll just go in here and look at all this, and man, the hoses and pipes all over the place. And you got to be just about be an engineer to figure it out sometime. But anyway, every car is going to be different, and some of them don't give any trouble with their evaporative system, and some of them give trouble all the time. And I've actually smoke tested some of them that I would have known I should have seen smoke somewhere, because they were telling me about a leak, but I couldn't find any smoke coming out anywhere. So you gotta get good at that stuff. I mean, I wish I had a nice little Pollyanna way of saying, if you do this and do that, you can always expect that. All bets are off on the way they do stuff nowadays, you know.
Not my fault, I was late.
Sit down, Mr. Differential Painter. All right.
Go, Jim?
No, I didn't get pulled over.
Well, if he'd got pulled over, it would have been his fault.
Well, like my car started shaking real bad, like vibrating, violently.
Yep.
So I was like, all right, might be time.
Next question on emission system test 8. We got right here. We're on question number what?
11.
We're on 11. Which of the following sensors is monitored for its operation and its heater operation? Oxygen sensor. Now, I told you guys what to do about this oxygen sensor heater business. I may have covered this with some people, but not with others, and I told Wes this. Wes, every time you change an oxygen sensor, you need to cut the connector off the oxygen sensor and save it. All right, now maybe I didn't tell you this, because sooner or later, you're going to come across one and you're going to pull a code and it's going to say, you got a heater problem. Okay, now you can throw an oxygen sensor in there and find out that your heater problem was somewhere else besides the oxygen sensor. If I've got a heater problem code to begin with, I'm going to measure the 2 wires that are the same color coming off the sensor, if it's brown or white or whatever. And those 2 wires, you ought to measure about 4 to 6 ohms. Hey, Judy, that's all right. 4 to 6 ohms on those wires. But if you take a light bulb and you wire it up to those 2 wires on the connector you cut off, and you plug it in where the oxygen sensor plugs in, unplug your oxygen sensor, plug this little thing with the light bulbs in, which would be, I guess I need to draw this to make sure. Alright, here. Here's your connector that you plugged in where the oxygen sensor used to plug in. And here's your little light bulb that you've got wired in there. I don't care how you hook it up, just hook a little light bulb in there. Alright, you plug that in, you crank the car, if that light bulb comes on, you know you got current going to your heater.
Yeah.
All there is to it. It's a quick and easy test. It doesn't cost much. You get some little 161 bulb sockets or whatever, or maybe the same one, and just alligator clip it to whichever one you happen to be using at the time. And, you know, and you can, if you want to get really cocky, you can unplug all the dadgum sensors and put one of these on each sensor and fire it up and see if they're all burning. You know, I've done that before. Now, one day we had this Chevy pickup that we worked on over here, and it had a leaking intake manifold gasket. We replaced the intake manifold gasket, but the mass airflow was reading nothing. Dead as a hammer. Totally non-functional, right? Okay, so the mass airflow sensor's got to have power going to it. It's got to have 12 volt strong power going to it, right? So we go to the mass airflow sensor and we unplug it and there's no power going to it. So we look at our fuses. See, you know, you can throw a mass airflow sensor on it, just assuming, but all of a sudden, bam, we plug it in and just like it would. You know, we don't go there. Let's check things first, okay? Let's make sure we diagnose properly. So we hook up our test light and we gently touch the terminal. If we don't have power there, then we find out the fuse is blown. The fuse feeding, you know, the circuit that powers up the mass airflow and whatnot.
Change the fuse away.
We put a fuse in there, pop. Pop that one too. Well, crud. Well, now what are we going to do? All right, so what we do there is, just like any other, we pull the fuse out of its little place where it goes. I'm just drawing that one little place, you know, on the thing. The fuse, we've got the fuse out of there and gone, right? There's our fuse. It's out of there. The fuse is gone. We're going to wire up a light bulb there and make it be a fairly strong light bulb, you know, like a light bulb, like a stop light bulb or something. And with this circuit powered up, that light bulb's going to be on bright, isn't it? All right. Now then, while some yo-yo watches the light bulb, we move around the car. We look on our wiring schematic and we find everything else that's connected to that circuit. And we start with the easy stuff to get to first, and we start unplugging stuff. While Joe is over here watching this thing, or we can see it ourselves, we got it shining, or maybe it's on a long cord where we can carry it with us wherever we go, right? You unplug this, that light goes out. You know what we unplugged and killed the light? The oxygen sensor on the right bank. Boom, light went out. The heater in the oxygen sensor was shorted, and it was popping that fuse. Not complicated, right? Okay, but the mass airflow was what was reporting dead in the water. The oxygen sensor was actually reading, but the heater went dark. See, the exhaust will heat the oxygen sensor up and make it work. So anyway, the oxygen sensor being shorted was killing the mass airflow. So that's how you find something like that. However, what if you unplug all the components and the light's still on? That's when you start jiggling wire harnesses and watching your light. You can jiggle them wire harnesses. Now, don't jiggle the wire harnesses unless you got something telling you what's happening, okay? You jiggle the wire harnesses if that light starts to flicker. Whoop, wait a minute, stop right there. Jiggle, jiggle, wiggle, on, off. Oh, look, it's touching metal right there. I see copper. Yay. Tape, ta-da. And then that's when the guy tells you, I've been all over town and I spent $725 and every other shop in town's put sensors on it, but nobody else has found this little place where the wire harness was scratching. How much do I owe you? You say $20. He'll be back to see you every time he needs work. And he'll tell everybody in town, these other shops put the screws to me and this guy charged me $20 to fix what they charged me $700 to fix. I have seen this, I've experienced it, and I'm telling you, customers really, really, really appreciate it. And sometimes not only will they pay the shop $20, they'll come back and they'll slip you a tip and say, you are really good at what you do and I appreciate you working on my car. That's the surgical repair. Now, they're not going to typically give you any kudos for jerry rigging. They don't really like that. Okay. Now let me go on. I'm plowing through too much of the morning. And okay, an OBD2 code starts with the letter P. The function of that device generated is what? Powertrain. Okay, what is a C code? Give me an example of a C code. What? C code. Come on, guys. You should know that.
A C code is something to do with the
chassis.
Chassis. Yeah.
Chassis, which would be like what? What's chassis?
Body chassis.
What about anti-lock brakes or something like that? Yeah. Yeah, but that's the thing. What about a B code?
Body work.
Yeah, body code is like theft protection or
Somebody
whatever.
hits you, but-
Well, that silly little box that you remember didn't you have U and B codes when you were pulling the codes in that little box? And the U code was the network was down. The B code had to do with body because it was actually, huh?
I said, give an answer now,
Yeah.
before you get to it.
Yep. All right, and then you got your B, C, U, and P. I mean, those are basically your 4 codes. U is always a network code. And don't be so terribly confused by all of that. An OBD2 code starts with the letter U, and that's what? Network. Which of the following OBD2 monitors involves many various engine sensors? That's number 14.
Misfire.
Comprehensive component monitor. See, there's some of these monitors, are looking all the time. Some of them can only look at something after certain conditions have been satisfied. OBD2 monitors are usually run during what?
All of the above.
All of the above. Cruising, acceleration, and idle. All right, let's pump on down here into OBD2 systems must illuminate, this is number 16, must illuminate the MIL if the vehicle emissions exceed the allowable standard for that model year based on a what? Federal test procedure. That is actually going to be abbreviated FTP. Can you remember that? FTP, Federal Test Procedure. Got it? The OBD2 requires monitoring emission-related components for both functionality and rationality. Functionality and rationality. The catalyst monitor detects the catalyst's ability to give off oxygen, to store and give off oxygen through the use of a what? What piece of hardware enables the PCM to determine whether or not the catalyst can store oxygen? The post-catalyst oxygen sensor. They call that downstream. And you might notice that on most cars, the downstream oxygen sensor has got a connector that's a different color than the upstream oxygen sensor. They don't want you swapping these around. I tell you what I had happen years ago was on this Thunderbird somebody worked on, they transposed the oxygen sensor connectors for left and right. And so what happens then is, it's kind of like when Grandma and Grandpa's got electric blankets, it's got 2 controls, and they get their controls switched. He keeps turning his down, and she keeps turning hers up, and she's burning him up, and he's freezing her out, you see? So you see these things going way out of balance. And they've actually got codes now that'll say oxygen sensor feeds are transposed. And it's possible if they're swinging right next to one another. How would you find out which way to plug them in right? I mean, to telling you about that without telling you how to plug them in the right way to start with.
The colors on the thing.
Yeah, you're going to look at that. Well, the colors on the front sensors are the same as far as the connectors. The wire colors are going to be different. So you look in your schematic and you say this one's got tan, black, and red, green wires, and this one's got yellow, black, and tan, white wire. And so you're going to make sure that the bank 1 and bank 2, which is going to be opposite on some vehicles depending on where cylinder number 1 is. All right. Now then, let's go down here. Number 19, the blank detects malfunctions that can result in fuel system rich or lean conditions. This is done continuously and involves the long-term fuel trim limits. Fuel system monitor, yeah. No, that's not rocket science, guys, come on. The term blank is a difficult concept to define since the requirements for it vary depending on the diagnostic test being run. The minimum requirement is that the ignition switch off period must precede an OBD2 drive cycle. That is a kind of a silly written question for a fill-in-the-blank trip, is what they're looking for there. Well, that'd be throwing you to the dogs to put something like that in front of you and make it a one-question test, wouldn't it? Once the mill is turned on due to a failure in the diagnostic for a DTC, if the system passes the test for that same DTC, how many times?
3.
3 times. Good answer. The answer to number 22, the data for the conditions at the time when the system first failed will be stored as freeze frame data. Only a few data parameters are required to be kept for this diagnostic help on the scan tool. And it's always important to look at that freeze frame data if you've got a code and it's one that you're going to have to, well, what are you supposed to do? Remember what I told you you're supposed to do first? You got codes, you clear the codes to see if they come back, right? Because for all you know, the filling station guy may have been, as if there was any filling station guys anymore, may have unplugged some wires and plugged them back in. You'll be chasing something that's not there. If you clear the codes, the ones that come back are the ones you need to be concerned about, particularly if it's one of those monitored all the time. But at the same time, you look at that freeze frame data and you record that stuff, and it tells you what the window was. The DRB3 scan tool that Chrysler used, for years, had a what they call a similar conditions window, which is kind of like freeze frame. So it would say whenever this condition was set, it would tell you they were traveling at this speed, at this engine temperature, and blah, 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 this throttle angle and all that. So you get out there and you duplicate the similar conditions window, and you're more likely to find the problem. 23, OBD1 used to service engine soon light, check engine light, another name for the same light. OBD2 uses the term, what? Malfunction indicator light. And number 24, many of the J standards, remember what I'm always talking about, J1930, J2788, and all these standards, they're published and established in OBD2 were organized by the Society of American Engineers. Look there, they put in parentheses the SAE, like you're supposed to know what that is anyway.
Some of those were established by the EPA.
Society of American Engineers.
Huh?
I thought some of those J standards were.
No, that's every bit of this SAE stuff. Yeah. Now the SAE and the EPA kind of work together in some cases. Evaporative monitoring requires the system to be pressurized or put under vacuum to detect a leak. Is called an enhanced evap system.
Enhanced?
Enhanced evap system is what the name of that is. All right.